Hello and welcome back. Today is day 11 of our Graphing Quadratics unit. We will be solving maximum area word problems. Just a reminder, a handout of this lesson is provided in the description below. Thank you and enjoy. Alright, remember these problems. These are coming back, I guess. The owner of a ranch decides to enclose a rectangular region with 140 feet of fencing. To help the fencing cover more land, he plans to use one side of his barn as part of the enclosed region. What are the dimensions needed to maximize the area? Alright, so let's sketch a little picture here. So we're going to have a little barn here. That's my barn. We're going to have some fencing. And remember, the fencing is going to have only 3 sides because we're going to use the barn to help out. Now, I would start defining some things. I would start labeling, well, I'm going to call this side X, and I'm going to call this side X because I know it's a rectangle, so I know the opposite sides have to be the same. And I'll let this one be Y. And then in this problem, they told us that we had 140 feet of fencing. So all that blue part right there is going to be fencing. So I'm just going to make a little note. So we have some fencing. And so I should know that 2x plus whatever y is has to equal 140 feet. That's how I'm going to make the 140 feet. And doing a little algebra, because I know we're going to solve this in a little while, it'd be nice if I just rearrange this to look like this, so that way we have y by itself. Perfect. All right, now, what else do we know? Well, we also know area. We know area of rectangles, so we know that the area of this rectangle will be, area is just length times width, so that'll just be length times width. And in this problem, our length and our width is going to be just x times y. But we also know that we also have a value for y. We know what y is, so we can just do a little quick substitution, and now we have the area is equal to x times 140 minus 2x. Perfect. Now, that's going to help us. We're going to be able to solve this problem now. So, what does that tell me? Well, when I look at that, if I was to distribute, if I was to multiply x times this value and x times this value, that would give me my second term would be x would be a negative 2x squared, which means it's a quadratic and it's going to be concave down. So I know that my graph is going to look like this. So let's sketch a little graph here and let's label this, and then we'll see what's going on here. So here's my graph. And what does x stand for in this problem? So x is going to be my length, so I'm going to say that's my length in feet, and my y value is going to be my area in square feet. Okay, because remember, x is the side length of our barn here. Now, the graph's going to be concave down, I know that. But now, what's the other thing that I noticed? So the thing that I noticed is that my area is written in a form that looks very familiar to me. It is written in a factored form. So as soon as it's written in a factored form, I'm like, oh, I probably can find my zeros pretty quickly. I probably can solve this real quick, and let's find those zeros. So let's see what those are. So I'm going to set each one of these. We're going to use the zero product property. We haven't done this for a while, but I'll set each one of those. So x equals 0. Well, that's solved already. That's done. And then my other answer for my other 0, we'll set the other one equal to 0. So we'll set this equal to 0. Okay, do a little algebra. I'll subtract 140 from both sides, so I'll get 2x equals negative 140. I'll divide everything by negative 2, so x will be equal to 70. So what does this tell us? This tells us our roots. We know our zeros, so we have a 0 at 0, x equals 0. We have another 0 at 70. So that means I have a 0 here, and I have I'll make another one right here. So this will be at 0 and this is at 70. And I'm going to have some kind of parabola that's going to look like this. Perfect. So what do we really want to know in this problem? Well, we're looking for this highest point. We're looking for the peak of this graph because that'll be the maximum area. Anywhere to the left of it won't be the highest area, won't be the largest area you can get. Anywhere to the right, so we need that highest point right there. That'll be the maximum area that we can get. And if we sketch down from there, what do we see? This is our axis of symmetry. So I really need to find my vertex. Now think back to, how did we find the axis of symmetry when we know our roots? Well, the axis of symmetry, let's write it over here on the side. So my axis of symmetry could be found by just doing finding the mean of my roots. Take your roots, add them up, divided by 2. So we're going to take the 0 on the 70. This is going to be a nice easy problem. 0 plus 70 divided by 2. So that my axis of symmetry is going to be at, I'll just simplify this, 70 divided by 2 is 35. So, and again, most of you might have already seen that. You're like, well, between the number in the middle between 0 and 70 is 35. So now we know the x-coordinate for my vertex, so we got 35. Now all we need to do to find the maximum area that we'll get will be just to do a little substitution. So let me create a little bit of room here. Let's create a little room right here. And we are going to use the little formula that we have. We're going to use our area formula. So our area formula was x times 140 minus 2x. And now we're going to substitute that 35 in there and see what we get for our value. So we're going to go a is equal to 35 times 140 minus 2 times 35. And let's finish that out. Let's just do a little bit of algebra here, or a little bit of simplification. So we got 35. 140 subtract 70 is going to be 70. So we're going to get 35 times 70. And I need a little calculator for this. What is 35 times 70? 2,450. So, what do I know? Well, that tells me that going back up here, where we're working earlier, that my maximum area is 2,000, let me change this to, is 2,450 square feet. So if one of our side lengths is 35, so if this side length is 35, that means the other side length must be 35 also, and your leftover for this side is going to be 70. So we know the dimensions now that will give us the maximum area for this barn. So if we use those dimensions, if we make one side 35, the other side 35, and 70 going across, this will be the maximum area that we can hold. That's to be the largest area we can hold in this problem. So our answer for this problem, let's just write it out real quick. So the dimensions are 35 feet by 70 feet, which will yield the largest area. Game over. That's it. We're done with this problem. All right, so let's go back and let's take a look at this real quick. So what do we do here? Kind of got a lot of work going on here. Okay, so first we sketched out our barn. That wasn't too bad. Using the information from the problem, we were able to sketch the barn. We had to use the information about the fencing to find really two formulas, one for the fence and one for the area. And then after that, we did make some sketches of the graph, but as we as we work this out, we're able to find the key information on this graph. So we're able to find the x-intercepts, and then after that we can find the vertex using the x-intercepts. Now again, some of you might have wanted to distribute, and you could have done it that way also. So again, remember, there's a whole bunch of ways to do this problem. If you wanted to, you could have completed the square and found the vertex that way also. But again, hopefully as you're getting better at this, you're starting to pick which way you want to solve the problem and which way is most efficient for you. All right. You should be able to do problems number 2 and 3 on your own. So I will write them up in a little bit, but pause the video right now, do problems 2 and 3, and then check your answers when you're done. Forgot to mention, I always like to look at my graphs and see what they look like and to double check my work. So I'm going to graph the equation that we had last time. So I'm going to graph y is equal to x times 140 subtract x, and perfect. Okay, now remember, we cannot see the whole graph here. We're going to have to zoom out a little bit. But remember what our y and our x-intercept was. Our x-intercept was 0 and 70. So let's zoom our x-axis. Let's go all the way to, let's make it go to 100, because that'll include 70. And let's see what we got here. And I don't see my answer. My bad, I know what happened. I didn't type my equation in right. There we go. So again, that's why I like technology. I get to really check and see what's going on here. So my function, I was missing that 2 in front of my x there. All right, so now, how come I can't see the vertex of this graph? Well, the height of the graph only goes up to 6. So I'm going to need to go up to, I think our answer was 2,000. Oh, it was 2,450. So that means we're going to have to go back to the little wrench over here. And let's make our y-axis go all the way up to 3,000. 3,000. Oh, and I see it already. Beautiful. So here we go. This is a beautiful graph of our problem. So what do we find so far? We found our zeros. Our zeros were at 0, 0 and 70, 0. And my vertex of this graph is exactly like we said, at 35, 2,450. Okay, so again, as you're going through the rest of these prompts, use decimals, graph your work, double check your work, make sure you know how to zoom, because again, if you're going to do a project later on, you're going to want to take a picture of this, a screenshot of this, and then include it into your project. So just wanted to give you a little quick summary of what we did. All right, hopefully you're able to solve this problem on your own. But let me sketch out a picture for us. So again, farmers love to build these, what is it? Rectangular region fences around their barn. And they love to use their barn when they're doing that. So here's my barn. And on this one, we're going to build a fence. And it's going to look like this. And it's going to have a little divider in the middle. So that way we have 2 equal areas. All right. Hopefully you labeled your sides. I'm going to call these x. Those are all the same. And my other side will be y. So we know that 3x plus y has to equal, and in this problem they said 300 feet of fencing. So we got 300. Okay, so that's just for our fencing. And for our area, well, let's solve this real quick. So y is equal to 300 minus 3x. So we're going to use that again a little bit. So my area for this problem is, area is just length times width. So we know this is going to be x times y, but we can do a little substitution to make our life a lot easier. And we're going to substitute what we know y is. Y is equal to 300 minus 3x. So there's my function that will tell me the area of my barn. All I needed to know is how long x is. So sketching a graph of this is going to be just like last time. It's going to be a quadratic. So we got our length in feet, and we have our area. Oh, I need a better marker. I don't like this marker. All right. So what do we know here? Let me see. Oh, well, let's solve this problem. So let's find our zeros. So my zeros are going to be my area is equal to x times 300 minus x. So I'll get 1, 0 when x is equal to 0, and I'll have to solve to find my other 0. There's a 3 missing. Minus 3x equals 0. Subtract 300 from both sides. We're going to work this out quickly. So x is equal 100. So I know right now I have a 0 at 0 and I have another one at 100. And I know my parabola is going to be concave down like this. And you probably can guess really quick, but I'm just going to write it out just so we get used to seeing it. Remember, we're looking for our axis that we want to find our vertex. And in order to do that, usually we need to find the axis of symmetry. That's what we studied before. So axis of symmetry, and we can use the little add up the roots and divide by 2. So x will be, I'm just going to solve this one because you should know what that is. What 0 plus 100 is 100 divided by 2 is 50. So we know that this is going to be at 50 right here. Now, the vertex is going to be at 50 and some y value. And let's figure out what that y value is. Well, in order to do that, we'll need to grab that equation again, the area formula. So area is equal to x times 300 subtract 3x. Perfect. And we're going to substitute that 50 in. So we're going to plug in the 50 and 300 minus 3 times 50. And then we're just going to simplify that out. So what do we get when we simplify that? I just did that right now. So that's 7,500. So that's telling us that the maximum area that we can get in this problem is going to be at, when our side length is 50, so let's write those in so we can see them. So when this side is 50, 50, this one's going to be 50, this one's going to be 50, and that's 150 so far, so that means this one's going to be another 150. Perfect. So the dimensions, what are the dimensions? The dimensions are 50 by 150. Perfect. So that's how big this this little fencing enclosure will be. All right, go ahead, 3's on your own, and again, go ahead and check this on Desmos. Check it on Desmos, make sure your answer pops out, make sure you get what we see here. Learn how to use the windows, learn how to zoom in and zoom out so you can see a nice looking graph there.